Okay, so this is the second week. So today we will cover data exploration. In many of the tasks that you'll be doing later at the third and fourth semester, you'll be doing some tasks. For instance, you will be doing classification, clustering, or even forecasting. So all those require the most important entity in the process, which is your data set. So whatever you plan to do, whatever you aim to achieve in a certain project, you must have the data set. So today, what we will be covering, we will look into the data exploration. We look at the definition. What are the tasks involved in data exploration? You will look at how this is very important because in any of the tasks, you should be able to understand the data first before you can perform any data analysis. For instance, like if you look at the diagram here, you could have your data from multiple sources and then you store in the database. Okay, so once you store in the database, then when you are given a specific task, then you can look at the data and you can explore. So explore means you are trying to summarize, you're trying to simplify your data, whether your data is relevant to the project that you want to do. Then after you understand your data, then you can do the data modeling. And then you deploy in the apps. Okay. For instance, if we are looking at specific area in which we are looking at the financial data. So what actually we want to do is we want to look at the pattern of the data that we have, whether we have increasing or decreasing pattern. We could also look into the relation between two variables, for instance, investment and profit. So we want to look at the correlation between these two. We also want to look at whether we have some outlier. Outlier refer to data which is away from the most of the data. So anomalies, data which is luar biasa lah. So it could be noise or you collect the data incorrectly, or maybe it's a hidden data that you should be looking at or focus on. Okay, so these are some of the examples that we can do when we do the data exploration. Okay, so by the end of the day, you should be able to understand why we need to do the data exploration, and then you should be able to explain the different types and structure of data. So there are two things here, the types and also the structure. And you should be able to perform basic exploratory data analysis, EDA, we call it EDA. And then how to use summary statistics and visualization technique in order to look into or understand your data. And lastly is to detect patterns, anomalies, and relationship. Okay? So these are the 5 learning outcomes that you should be achieving by the end of the day. And with this learning objective, this is what we want to cover. So we will introduce what is data exploration, and then we look into the different type of structure and type of data that we have. And then we look at some of the metrics that we can use to summarize your data. And then how do we detect patterns and anomalies? And lastly, how do we handle missing data? Because in most of the cases, we will have this missing data because of due to few reasons. We will look into this one in detail. Okay, so let's take a look at the first one. What is data exploration? Okay, so the definition of data exploration can be coined as follows. Data exploration is the initial and critical step in the data science process in which we look into the data and then try to simplify, summarize, and then if you have the tools, you can visualize the data set in order to look into the trend, the pattern, relationship, and also the anomalies of the data. Anomalies refer to noise or something which is weird occurring in your data set. So this is the definition. This is the first step that we need to do in order to analyze your data, summarize, and then visualize your data. Okay, so we normally call them as EDA. So when you go into third year, second semester, you will have project one. Okay, so project one. So one of the process in your project, you need to perform EDA, which is exploratory data analysis, in which what are the methods you use to analyze or to capture any trend or to detect any anomalies. Okay, so think of data exploration as getting to know your data more, understand your data, what does the column means to you, and then you asking question before jumping into conclusion, because sometimes we assume the data are perfect, there is no error in the data and so on. We can also think data exploration as looking for clues, pattern, and problem. Okay. So why do we need data exploration? Okay. So like I mentioned just now, before we do any modeling, we look into the data first. Data is the first entity that you need to get before you can propose any project. For instance, if you want to look at forecast the price of the gold, okay, so you need to have access to the time series data of the gold price for 10 years, and also at the same time you want to look at the micro and macroeconomic factor that can be used to forecast the price of the gold. Okay, so that's why before we can build or before we can do data mining process, we have to look at the data first. So we must look at the data and see whether we have missing value or value which are out of range. We want to look at how many columns we have. Okay, and also are these variable interrelated, and at the same time also we want to look at whether our data is imbalanced or have bias and so on. So imbalance meaning that, for instance, you have one data set, okay, one data set, and you want to diagnose a cancer disease in which 90% of them do not have cancer and 10% of them have cancer. Okay, so in this data set, we have imbalanced data set because 90% of them do not have cancer and 10% of them has cancer. So for us to model our method or to train our model, we will have problem because we have imbalanced data here. Okay, even if your model is able to predict 90% of them and fail to predict this, you still have 90% accuracy. So that's why imbalanced data will give you problem. Okay. Okay, data are biased. Okay, for instance, we have one set of data. Okay, we will look at the same data here. So we look at the data for cancer, and this data consists of 5% male, okay, and 95% female. So this one does not represent the population, because in an ideal population should have 50-50. But in this case, female 90%, male is 5%. So we will have biased data here because it's more prone to female. Okay, so that's why it's very important for us to look into this, the percentage of each of the category that we have. Okay. Okay, so with data exploration, we will not be able to detect missing values or trying to find the relationship between two variables and detect imbalance and bias data. So what happened to our model? We will have a model which produce misleading result. So inaccurate, or they are biased towards certain population. Okay, because they're learning from incorrect data. And for that reason, they fail to generalize the whole population, because let me erase this one. Because when we have the whole population, this is your population of your data set. For instance, this is all the patients for cancer. This is the population for the whole world. But since you cannot get all the data, so you want to get only a sample here. So this is your sample. Okay, but it turned out that your sample here consists of 10% cancer and 90% non-cancer. So this is imbalance. And at the same time also, you have 5% male and 95% female. So this is bias. Okay? So for that reason, since we will have this, we are not able to generalize the model for the whole population, because we just take a small sample only. So if the model that we train cannot be trained using a good data set, then we will not be able to generalize the whole population. We cannot use the model to represent the whole population. Okay, so that's why we need to explore our data set. Okay, what are the key activities in data exploration? So this is some of the things that you can do or propose when you want to propose a project. Okay? So the first thing that you need to do is you need to understand the structure, the number of rows and columns, the data types that we have, numerical or numerical. So numerical refer to any column or features that consists of numbers, numerical in terms of decimal point or nomor bulat. Categorical value refer to any of the column that use categories. For instance, for gender, male and female, and then for grade, we have A, B, C, D, and so on. Okay, so we can use also statistics in order to summarize our data. So we can use the mean, median, standard deviation. So I believe all of you know how to find this. We can also use the tools for visualization. So we can create histograms, scatter plots, and box plot. Okay. And lastly, we can check for missing values, duplication of data, and outliers. So these are the key activities in data exploration. Okay, so you should be able to, when you look at the data, you should be looking at all those methods that you can use for trying to understand your data. Okay. So for instance, like this one. So we have this raw data, and then we know that we have missing value here, right? So at the same time, also we have possible outlier here. Okay, so these are the sample of activity. Okay, and we can also use histogram here, visualization technique. So in which we can see that majority of your data falls here within the 70 and 90, and we have one extreme value outlier, which is here. Okay. Okay, we can also use the scatter plot. For instance, okay, we can assume there is a trend here, but we also can see that there is an outlier. This is outlier, where the data is positioned away from the rest of the data. Okay? So we could assume also there is no strong relationship because of this, because too far from the line here. Okay, a strong relationship is that we have this point closer to the point that we want to draw. Okay, so one abnormal, which is the outlier. So this is some of the examples that you could do when you look at your data. Okay, for in the practical, later on we will do all of this hands-on. Okay. Okay, so now we go to part 2. So part 2 looking into the structure and the type of data that we have. So the first thing that we have for the structure, we have two only, which is structured and unstructured. Okay, so structured refer to all the data that organized in format table, row, and column. Okay, they have fixed schema, easy to store, and normally they are stored in the database. Okay, or Excel or CSV file. Okay, in contrast, if we look at the unstructured, we have no fixed format. We have text, images, video. So this comprises 80% of your data. So this is only 20%. Okay. So there is no clear schema. Schema means template to store them. Harder to organize because normally we store them in the folder or in a specific big object database. So other example like emails, social media posts, images, video. So all of these carry a lot of information. So how do we harvest them? How do we collect them and then process? That's another task area, which is what we call the text mining. Okay. So if we try to compare the structure and unstructured, so for the format for the structure is tables, this is not organized. the storage database, but for this one is files, media, text. And to do the analysis is easy for the structured. For unstructured, very complex. And if you look at the general description of this, let me erase. Okay. So we can differentiate structured and unstructured data. So based on some features, for example, the can be displayed in tables where unstructured cannot. And for structured data, it consists of number, date, and string. But this one is of big, large object, which is audio, video. So 20%, this is 80%. This one require less storage. This is require more storage because most of the data here are big size. So this one is easier to manage, and this is more difficult to manage. Okay, so depending on your task, if you want to do certain tasks, you want to know where your data coming from. So maybe your data coming from the social media. So social media data is considered as unstructured data. But most of the data that we have is for data mining. They are stored in tables. Okay. Okay, that is the structured and unstructured data. So now we look into the different type of data that we have. We have for numerical data, we can have discrete and continuous measurement. So discrete means nomor bulat lah. So this one is decimal point. Okay. And we could also have categorical data. So this is, we have two, which is nominal and ordinal. Ordinal, they have order, for example, low, medium, high, or maybe you can have A, B, C, D, E. So A has higher value. For the nominal one, we don't have any particular order. So gender, we have male and female. The country, we have country, but there is no particular order. Okay. So these are the two main type of data that we have. Okay, so how's everything doing? If you're okay, can you type number 717? Okay. Okay, so for this lecture, we will have a quiz online. Huh? So I will arrange the online quiz for this one. So now we look into part 3. So we have covered part 1, which is definition of data exploration. The second part is the type of data that we have. And then now we look into the summary metrics that we can use in order to explore our data. Okay. So summary statistics are numerical values. So these are some of the numerical values derived using certain formula that we can use to look at the center of the data, how the data are spread from the center of the data, and then we look at the distribution of the data. Yeah, so we have a few method that we can use here. Okay, the first one is how do we measure the central of the data. Okay, so normally we can use the mean. Okay, mean is just the average. So we sum up all the value divided by the number of items that we have. So this is sensitive to outlier because outlier, for instance, if you have outlier 150 here, okay, so this is outlier. This will make your means bigger away from this tree. Okay. So so that's why it's best to look at the data. If you have potential outlier, remove them, or maybe you can take note because maybe that is the actual data that you have. Okay, so for the median, we just take the middle value of your data set. Okay. So this one will not affected by the outlier. And the third one is the mode. Okay, the mode refer to the number of value which is occur the most. So in this case, we have the 80 here. Okay. Okay. So to measure how far your data are spread from the center, so we call it the measure of dispersion. So we can use the range. So the range is basically finding the max value and mean value, and you find the difference. Okay. So in this case, this is the 40 lah. The limitation, we only use two value, which is the max and mean. And the second one is the variance. So the variance is basically the average of square differences from the mean. So we take the differences and then divide by n. Okay? So n is for the whole population and n minus 1 is for the sample. So you can either use this or this one. Okay. And okay, so the third one is standard deviation. So standard deviation is similar to the variance. They just square the value of the variance to make it smaller. Okay, so this range, variance, standard deviation, I believe should be no problem for you guys. Okay. And the other metrics that we can use is, for instance, we can use the minimum and maximum value to look at the range and also the possible outlier and quartiles. Okay, Q1, Q2, Q3, and Q4. Okay, so this is very important if we want to look at for outlier. Okay, so for instance, let me show you how to compute the IQR. Okay, for instance, like this one, we have example data set here. So what we need to do is we need to sort them, because what we need to do is we want to divide them into 4 parts. Okay, so first, second, third, and fourth. Okay, so so we need to sort them out. So we will have this. Okay, so once we get the sorted data, we will need to find the median. Okay, so the middle of the data set, which is the 22. So our quartile 2 will be starting from 22. Okay, so we mark this one as our quartile 2. So what we need to do is we need to find here the Q1, the Q3 and Q1 here. So how do we find that? We just find the median. Okay, we split them into 2, and then we find the median from this first and from the lower half and the upper half. So we will get this value, and then the IQR can be computed by subtracting Q1 from Q3. So we get this one. Okay. So our IQR is 16 here. So what it means that the middle 50% of data lie between 65.5 to 32.5, which is, if I go back here, so our Q1 here is this one, and Q2 is around here, Q3. Okay. So what we can do about this one. So the formula to check for the lower bound is from the Q1 we subtract 1.5 times the IQR, and then for the Q3 we plus, because we want to know how far they can extend to the left and to the right of your data set here. So this is 1.5 IQR. Okay. So what we have here is this one and this one. So that means if I have my data here, so the limit is minus 7.5, and this is 56.5. So if your data is over this and less than this, that means they are outlier. So let me clean up this one. So the limit here and here, the limit here is minus 7.5. The limit here is 56.5. Okay. So if you have data falls below here or over here, they are outlier. Okay. So since all the data is within this range, so we say that there is no outliers. So the final result is this is your line for Q1 is 16.5, Q3 this IQR is 16, okay, and so on. So in the practical lab, we will go through this one using the R software. So don't worry. So we look into this one. So any questions so far? No? Okay. Can you type number 333? Okay. Thank you. So those who are still here. Okay. So now we go to part 4, which is how do we detect pattern and anomalies. So in this stage, what we want to look for is some pattern or anomalies. Okay. Now patterns mean frequent pattern referring to regular behavior, and then anomalies something which is unusual. Okay. So for instance, we can plot the trending here. So we can see the pattern whether it increase or decrease or stabilize. Okay. This is the trend. We can look also the cluster or grouping of data that we have. So in this case, we can assume that we have 3 clusters here. So depending on the data that you have, you could have 5, 6, and so on. So using the visualization tools, we can visualize this. We could also, based on the trend, we can also look at the correlation, so positive or negative or none. So correlation can also be computed using the tools that we have. Okay, and lastly is the anomalies. So remember just now when we mentioned about the median. So this is box plot. So the box plot automatically define where is your second Q, which is the median. No? So this is your upper bound, this is your lower bound. Okay. So how we compute that one? So this one is this is the Q3 plus 1.5 times IQR. So this one is Q1 minus 1.5 times IQR. Okay. So this is the line that we have. So we will do a practical on this. How do we plot this one? And then if something fall outside here or below here, they are called the outliers. Okay. Another example is that based on the data, for instance, the price of the house or the price of a car or the price of certain item. So if we have a data set on the price of the car, we can plot this one, box plot. And then if you want to determine whether the car is overpriced or underpriced, we can check from here. But you need to have all the data in your data set. Okay, for the same model, same car, and so on. So that's good about this. So business in people in business or in finance, they use this box plot in order to determine whether the value is within the range or outside the range. Okay. Any question?
No, doctor.
Yes, Z. Okay. Okay, now we go to the last part. So the last part we have a bit detail here because this is the most critical part. What happens if you have missing data? So what can you do? Do you remove them or do you try to change, or you have a default value for missing value in your data set? Okay? But there must be some reason why the data is missing. So we look into that. Yeah. Okay, so the missing data occur due to the first one, which is missing completely at random. We don't know why. Okay. So this missing value has no relationship with any data in your dataset. They occur purely by chance. For instance, a student missed an exam because of a fire alarm. So in the record of the student record, fire alarm is not part of the variable that you have, right? So if the final exam score is missing, so this is by random only. Maybe the student got sick or bangun lewat and so on. Okay. In the second example, a survey question is skipped excellently means the survey question is not answered by the candidate because they forgot or they missed that. Okay. So the key idea here is that there is no pattern that you can look for in order to solve the problem. So the best thing is to remove or ignore in many cases. Means you will delete. You will delete the column or you will delete the row, because there is no way you can make up or you can replace the value, right? So we don't want to have a missing value here. Okay, so this is missing completely at random. Okay, the second part is missing at random. Okay, so the definition is missing value are related to other variable but not the missing value itself. So meaning that if you have this variable a, b, c, so the missing value is here. The missing value is due to the fact that it has something to do with the other variable here. Okay, so for instance, a younger students are less likely to report income. So, for instance, this is the age, this is the income. Okay, so maybe if you are just graduate, so you don't want to display your income due to the fact that you are fresh graduate, okay? Or a student with low attendance are most likely to miss the test. So, for instance, you have this data set, and this is the test, and this is the attendance. So your attendance is low, and there might be missing here. Okay? So in this case, we somehow we can figure out what is the value here, depending on the other value that we have here. So that's how we will solve the problem here. Okay? So the key idea is that there is a pattern here, and we can often handle the situation by using the statistical method. Okay. Okay. Third, missing not a random. So missing not a random, meaning that missing value are related to the value itself. Okay. For instance, high income individual choose not to report income. So for instance, you want to do study about a certain socioeconomy. So this is the ID and this is the income. So they do not want to expose the salary because of high income. Because maybe they want to apply for scholarship or and so on. So that they don't want to expose the income here. Or which don't skip exam because they expect low score. Okay. So the key idea is most difficult to handle because we do not have pattern. So normally we have to do some analysis, or we, we can use some advanced technique how to replace the value. Okay, okay, how to handle them. So strategy number one, remove the data. So for instance, like this one, so we can just remove Bob. Okay, so this is especially can be used when you have this. Okay, because this one there has missing completely at random means there has nothing to do with the other variable. So you cannot predict, you cannot generalize. So you have no pattern. So the best way is to remove the data. But if you remove the data, then you will lose some loss of information, or it can reduce your data set size. Okay, strategy number 2A, okay. Fill the missing value, so by imputation. So for this one, for number, what you can do is you can replace the missing value using the mean. So this is for numerical values. Okay, so you will replace with 80. Okay, for the category value, you can replace using the mode value. Okay, so the mode is B, then you can replace the missing value with the B. So this is best for categorical values. Okay, so these are some simple guide. Okay, so for categorical value, you use mode. For the numerical value, you can use median. For missing completely at random, you can remove or you can impute. Okay, but in most cases, we remove because there is no trending. But if you have many missing value, many means you have few rows, few column that has missing value. We can use machine learning, but you will have many bias result because your data is not primary data, because you fix using substitution of values. Okay, so let's do some testing here. Okay, this is the question that we have. A survey dataset shows that some response are missing because participants accidentally skip question. So what type of missing data is this? What is the best way to handle this one? So you need to answer whether this is missing completely at random or missing at random. And the last one is, what's the last one? Oh, missing not at random. Okay. So please type your answer. So this one we have a survey data set, but this person accidentally skip question. Okay, what type of missing data we have here? Ian say missing completely at random. Yep. So this is missing completely at random because they accidentally skipped the question. So we can remove them. Okay. Second one. Salary dataset, hire earner tend not to disclose their income. So what type of missing data is this? Very good. So missing not at random. So for this one, difficult to replace them, to handle them because we need to do some background checking. Okay, for this one, given the following data set, what type of missing data is this? So for this one, we can relate the score with the attendance, right? So maybe the student did not turn up because low attendance. So this is missing at random. Okay, so missing at random, saying that your data here has some relation to the other feature that we have. Okay. 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 So here is the conclusion for the missing at random, because missing at random, they have something to do with the variable. Okay. So for instance, like this, we have score 85, 75, and missing value here. Okay. So how do we replace with this value? Okay, how do we replace this value? So what we can do is we can do the group base. So which means that we look at all the low attendance score, and we take the value here to replace here. So this is group base. So group base, you look at the average. Okay, you look at the average. We could also use regression imputation, which means that we look into a few variables here, because the other student also have the value for A, B, and study hours. So based on the regression value here, we can predict the score and put the value here. Okay, you will learn more about this regression. Okay. Okay, if you have multiple imputation, this is when you have more missing value. So you take the average value, or you can use machine learning to predict the values. Okay, so this is more advanced technique. Okay, so later on we will learn more about this. Okay, so choosing the best method for missing data. If you have simple data set, use median and mean. If you have a group data, then you can use the the group-based imputation. So this is missing at random normally. This one also missing at random. So this one is missing not at random because we do not have any trend, so we can use machine learning. Okay. Okay. So we have covered the whole 5 parts. So the key takeaway here is that you need to do data exploration because this is the most essential part, I believe. Before you can prepare your data, you need to understand your data first. So what column represent what description, and then you have to look at how many data type you have, string or numerical. Do you need to combine them, or do you need to construct new features? You need to be able to use tools to visualize the data that you have, or 3 reasons to find the trend, to find the grouping, and then to find the outliers. Okay, and when you have missing data, you need to be able to handle them. So there are a few things here that you can, few methods that you can use, but it depends on what type of missing data that you have. Okay, but if you have thousands of them, if you have 10,000 data and you have 1,000 missing value, normally we just remove them from the data set. Okay. So any question?